Which one? This one? Oh, okay.
Is there a specific like page that we do the look at?
I can.
Where did you get yours from?
From the park. You want to take a picture of it?
I think you're supposed to look at them under a microscope. They're not insects. Just like it says there, if you read 612, go ahead and read it out loud for me.
There are many different species of plates in the ocean. The ecosystem show different similarities and differences between the two organisms that you observe. Did you notice any specialized features in the state of the
Where is that in your notebook? No. Where are the drawings for part A? Because you're on part B. What it's asking for is, you have the drawings for part A.
Yes.
Okay. What specialized features did you observe in part A? Now, so your notebook, what do you have for part A? What is that? What power is that? You have to redo it. Divide the guesses under 40x, which is what I said, you probably need to get closer than that to actually see stuff. Right, otherwise it looks like stuff from very far away, right? So I looked at this under 100x. The same drawing, you see it, the same picture, you see it there. So I have it sketched in my notebook, right? Okay, and then what specialized features do I see, like inside or outside of this organ? Yeah, so it looks like it has like organelles or little like sac structures inside to hold stuff. Sac structures or organelles or organs. anything else? Look at that picture, anything else you notice? Hmm? Any specialized features?
It looks kind of blurry.
The bottom of it is blurred because it's so big that when the top is in focus, the bottom is out of focus. It's kind of like when people are standing in a picture and somebody's far away and somebody's close. One person's in focus and the other person's out of focus. What else? Look at the top of it. Some hair-like structures, right? So if you look at step number 12, read step 12 again. So I noticed two specialized structures in this picture. The sac-like organs and organelles, also the hair-like structures on the top, right? What you need to do is have one more observation. You can use that one, but then what other one are you gonna do? That one looks like it's a little unclear. Too far away to see the living organs. So maybe you wanna do that part A and finish that, or you can borrow data from another team, and what they got, and you can compare what they got and do the same thing, right? Just make sure you give credit to them, right? Go ahead and read step 13.
With your partner, examine the drawing that plates in figure 6.5. What specialized features do you notice?
Good. So specialized features, we talked about little hair, right? Those structures we see that make them that look like they do something for that organism, right? Right? So you're gonna do that. What does step 14 say?
Use switch 6.2 classify 14 to classify each plate. You observe as either a producer or a consumer based on their specialized specification. A producer is an organism that produces food. A consumer is an organism that consumes food or either of the organisms. Most of the plates you will see multicellular organisms.
Okay. Good. So it's saying to look through the next slides. Okay? And they're up there. Where all the other microscope equipment was that you were using on when you came in during lunch.
Los similares son esas.
Does that answer your question?
Es como ese.
Este es la que se parecen.
So what do they mean by specialized
¿Se
structure?
parecen o no? ¿Algunos?
Lo que no. No.
Like
Como
sac-like
nos parece
structures,
este
like
y
organs,
este
looks
y
like,
este.
or
Pero
hair-like
se puede
structures.
hacer este y este.
Sí.
Puedes decir eso si quieres.
Possible function.
Que algunos sí se parecen.
Ujú.
What do you think the sac-like structures is? What do you do?
Which species is
I don't know. This is something I looked at underwater. What are hair-like structures? What could they do?
local actions?
It could serve as defense. Okay, you could write that down, so you could write, it could serve as the defensive system to keep bacteria away. That's what you have to do. You just have to look at the structure and try to think, what would it be there for? Right? Because obviously evolution has made these guys survive. For some reason, they are suited well for their environment. For some reason, they're able to survive. What are they doing? What features do they have that make them successful? Right, we can see color. That allowed us to go find food when we were moving around as nomads, as a species. Because we weren't always farmers, right? And then we learned how to farm, right, because of our big brains, right? Okay? So we also walked straight upright, which allowed us to travel great distances, right? And go through all of the Middle East and all through Southeast Asia, all the way to the Americas, right? So That's a feature that you try to just predict, like, what is the feature, and why does it benefit us, right? Or benefit the organism. And we're just trying to make sense of it. We don't have to have the right answers right now, we just wanna be thinking.
So the whole part of this stem tool, like I say for them, their specialized structures is they have hair-like features, and their like features can is a defense mechanism.
It could be.
Could be.
And you wanna go through and look at the other ones that are under the slide, because those pictures don't do justice to what these organisms look like. Questions? Yes. Have you finished part A? Alright. So, what did you draw?
Tú lo que ves tienes que escribir. Claro.
No, pero eso es de los que-
Well, let's read step, what is it, step 7, 8? Alright, what does it say?
Uy, ese de eso.
Step 8, step 18. Uh-huh. So what two organisms did you observe when you looked? That was one of them that I observed when I looked under the microscope slide. Right? What did you see when you made your microscope slide? What power is that? Oh, you gotta do it again then. You didn't write down what power, so you can use that data. Right? What you wanna do is try to get to at least 100 or 400x, so you can really see. This was observed at 100x. Let me see. Looks like 40x to me. That's why I'm saying I think you should redo it. Yeah, looks like 40x. Right, now this is the picture. Right picture. Hold on. I mean, you could actually make it 100 by doing this, right? Doubling it, because double 40 and you get 80. But what we want to do is focus in on just one of the organisms. That, or this, right? No. But which one of those are you gonna draw? I'm gonna draw one of these. Cause I saw one of these in my slide too. Is that 400x? Actually, 100x. If you want, you could draw one of the other structures. They don't look the same, right? because what I did is, your picture I think was at 40, but what I did is I just zoomed it up, like more than double, right? And so if I think about that, if I'm doubling 40, it goes to 80, but I went a little bit more. So what I could say is I could say approximately, because it's an estimate, because we use the zoom in on the phone, right? So let's just talk about this. Between this, you can take my picture if you want, right? Or you can find another organism from that same slide, or you can make it another slide. It doesn't matter to me. But the point, well, it does, because I want you to be good at making slides, because that could be a job. But what do we see? What specialized structures do we see? Little hairs, right? We talked about that in yesterday's class, right? Somebody said today, these little sac-like structures, right? What do you think these sac-like structures do? What do you think? Nope. They're inside, right? See these little sacs, right? Do you think this is protection? What do you think it could be? What's that? We're doing this investigation with the microscope slides, which you should do, because those slides are here in the classroom. I'll give you another scaffold for your notebook. So there's 8 sets of slides to look at. And what we want to try to do is figure out if they're producers and consumers. Producers or consumers. Okay. What do you think the hair-like structures do? Okay, it could be used for protection. All right. What about this one? This is a little hard. I wrote that it kind of has like a rigid shape to it, right? It looks like that one, doesn't it? Yeah. So it may be that that's what it is. I'm not sure, right? Because it's not labeled, right? Like the slides that we're going to be looking at that are prepared. What is that one called? Oscillatoria. Possibly. What does it look like to you? Like if you had to describe what it looks like, what would you say, Zara? Looks like a worm. I said it looks like a stick, right? Why are worms the way they are? Why are they long and skinny? Does that give them a benefit? Okay, maybe it makes them easier to move or transport or drag themselves around. Why are sticks long and thin? Why does a stick need to be long and thin? You're thinking about branches on a tree, right? Why do you think branches are always like, they're never like fat and short, they're usually like long and thin branches, right? Mostly. Why do you think branches are long and thin? So that something can reach out and hang off, so it can reach out and have something hanging off. Why is grass like long and thin?
Because it grows.
Why does it grow long and thin?
Water.
That's not an explanation. At least you said because it grows last time. Now you're just saying water. Why is it long and thin?
Talk to me.
Yeah.
That's how grass is.
It's just because how grass is. Well, that's a big concept, right? We could think that like God just made things the way they are, but what we know is that things actually change over time, right? If we look at evidence, we see that it hasn't always been that way. right? Things have evolved, right? So what we want to think about is what causes something to be successful? Why is this structure successful? What structures does it have that make it successful? It could be because it's like a worm, so it allows it to move through the water very quickly, right? To drag itself. Could be. We don't really know, but we want to be thinking about it, right? And trying to understand it that way, right? So even if you don't get it right, I want you to write down what you think, okay? Because that's how we build understanding. When scientists figure something out, it's oftentimes, it starts with an idea, and then we get more and more evidence to prove whether it's true or not. I thought I heard somebody knocking at the door. Was that you knocking? So what I would do, if you're ready to start part B, is I would go back to
So are we doing
find
part
a
B or
microscope table, and I would start going through the slides and putting the slides on the microscope and looking at copepods, right? And seeing what they have, what specialized structures they have, right? You could try to do it from the pictures in the book, but if you look at the instructions for the activity, it says go get back to the microscope and start looking at slides. I have 3 boxes of these slides for people to use to look at. So I encourage folks to do that. There should be 8 slides in each box. And then make sure you pop that door open so you don't have to knock and wait for me to come back. I think a lot of teams are on part B. So I'm just gonna put it on that slide for right now. If you finish with part B, obviously you're gonna go to the build understanding. But the part B slide you can find from yesterday's slide deck. And it is slide number, I believe it's slide number 30. 29 and 30. So, observe the prepared plankton slides and try to classify. We want to look at more than one organism, so the slides are a great place to look.
Why does the color stone looks like green peas?
Huh?
It's like green peas.
Why do you think it looks like peas? Does it really look like that? What if we look at it under a microscope?
No.
Have you looked at it under a microscope?
I haven't seen that.
Well, then let's, instead of making up evidence and say, no, it doesn't always look like these, why don't we actually look at them? So these are just drawing, like sketch drawings. I have actual Clostridium to look at in the classroom, right here in the back.
Nice. What is a clostridium? It's an organism.
Of plankton? What do you think it is, a producer or a consumer?
Looks like a producer.
What's the difference between a producer and a consumer?
A producer is an organism that produces. A consumer is an organism that gets something that eating other things.
Okay. Good. So you said you think that Clostridium is, what'd you say, producer or consumer?
Producer.
Okay. What makes you think that?
Oh, because it doesn't look very strong to eat another organism.
Uh-huh. I would agree.
Looks
What
like
did you describe it as earlier?
And
it eats.
Yeah, like you described it like a vegetable, right? Some of them are. Mhm. Yeah? Good? Yeah?
I know a copod is most definitely gotta be a consumer. Is that correct?
Copepod is a consumer?
Yeah.
What makes you think that?
It has like spikes. And it has like antennas.
What do the antenna do?
It's probably like sensitive to heat or something.
Okay,
Another organism.
alright. I like the way you're thinking.
And it has like one eyeball.
Okay, so it has something to see. That's something that senses light. Good. I like your thinking.
What is it just justification for a classification as
That means, why do you think it is that way? Why do you think it's a producer? Why do you think it's a consumer? I'm asking you those questions, you're telling me, right? So now you just have to write it down. How we doing over here? Have you started looking through the microscope? I encourage you to do that.